Are we doing the back page? Do you want to?
If you're done with the front page, you can do the back page. I doubt that we're going to get there in the time remaining. Given that I have 4 minutes left that you're paying me, I'm glad to stay longer, but I know you aren't. Let's talk about that first page. We're first of all asked to compare A versus B. This is very easy because A is an indicator bulb for the entire circuit. All the current that goes through the battery goes through A, but only part goes through B. Mathematically, I would write that as the current through A is equal to the current through B plus the current through C. Some of it goes left and some of it goes right. Now, the next part is more challenging. B versus C. And here we're deciding, when it gets here, which is the easy path and which is the hard path. And the way we answer that is by drawing both paths identical. If that were the circuit, if there were no bulb F, it would split 50-50 below bulb A. Is that right?
Yeah.
By adding bulb F in parallel, I made this the easy path. So that means that more than half is going to go this way, and less than half will go the hard way. So that means that C is going to get brighter than B. Well, what about B versus D? Equal, series. That's all you need. Now, D versus E. That's a pizza, okay? D is going to get all of this small pizza, and E is going to get exactly half of that large pizza. So today I can't answer that question. On Monday I will be able to answer that question, and I'll show you how. Now, in this problem on the first page, we're asked to unscrew bulb E and leave the empty socket behind. I just removed a path. What happens to the current through the battery? Goes down. What happens to A? It's an indicator, so it gets dimmer. Now if I look at bulb C, without bulb E, this path looks like that path. This branch goes from being the easy branch to being exactly the same as the other branch. That means C's share of the total current goes from more than half to half. Its share of the total goes down, and the current through the battery goes down. It's being shared. What happens to C? It gets dimmer. It gets dimmer. Okay, that's a good stopping place. We'll pick this up on Monday. Have a good weekend. Start with this problem that we started last day. We finished the first side. We haven't started the second side. Let's just remind ourselves what we found on the first side. When we were comparing A versus B, we said that A was brighter, and it was an all versus part argument. A got all of the current through the battery, B just got part of the current through the battery. When we were comparing B versus C, what we're talking about is the splitting ratio right here. Does it split 50-50 or some other way? And if some other way, which side gets more than half? Well, when we solve problems like that, we draw the two paths identical. So this would be A, B, D, C, and E. And in that case, the current would split here 50-50. And then we ask, what's missing? Well, there's this extra bulb on a new path that was added in parallel. That's going to lower the resistance of that path on the right, and that means it's going to split with more than half going the easy way, less than half going the hard way, and current favors the path of least resistance, so C is brighter. When we compare B versus D, we just say they're in series, so they're equal. When we compare D versus E, we got a pizza problem. D got all of the small pizza, E got exactly half of the large pizza. We couldn't answer the question. Before the end of this lecture, we will be able to answer that question. Now, turn the page over. In this case, we take a connecting wire, and all of our connecting wires we assume have zero resistance, and we place it from point 1 to point 2, connected. And my first question with your clicker is, does C go out yes, no, or I don't know? Yes, no, or I don't know. Okay. Oh, we don't know. We don't know. Okay. I can actually hook this up. There we go. Okay. Yeah. Now, I'm missing a bulb. I'm missing bulb A, but there's B and D, C, E, and F. And I'm going to hook these up. And let's see. That goes to there. That goes to there. Oops, no. One more. Be done. Okay. C is brighter than B, and okay. Now what I'm going to do here is I'm going to connect a long wire. I'm going to connect it from here, in between B and D, to right above C. Right over there. Did C go out? No or heck no? Heck no. Okay. Okay. Now, that was a little bit cheating because there wasn't a bulb A there, and but it's not going to go out in this case either, for reasons that we'll talk about in a little bit. Now, what about bulb B? Will bulb B go out? You all just watched. If you don't get this right, I'm worried about you. Okay. Last call. Oh. Whoa. I would have thought that would be a slam dunk. Here's the big idea. These circuit diagrams only tell you what's connected to what. It doesn't tell you where the wires are laying on the table. And a general principle that we will understand before the end of today is that I can take a connection and move it along a wire anywhere I want. And I do not change the circuit or the brightness of any of the bulbs as long as I don't move that connection across an element like a bulb, a switch, or a battery. I can move this connection anywhere I want without changing the circuit. Have I changed the circuit? Have I changed the circuit? Have I changed the circuit? No. And now it's clear that B is shorted out. Well, wait a minute. Why would it go through C when it go through an easy path? Well, the easy path still has to go through bulb D. It's not a wire path. It's not a zero resistance path. It's still got resistance on it. This is just easier than this path. So C is going to go from getting more than half of the current through the battery to less than half of the current through the battery. Okay? Now, let's do the last part of this, the last page of this problem. What happens to bulb A when I add a path to this circuit? It gets brighter. I've added a path, I've lowered the resistance of the circuit, the current through the battery goes up, and A is an indicator for the battery. B goes out because it's shorted out. What about D?
Brighter.
Brighter. It's now getting more than half of the current through the battery. It used to get less than half. Its share of the current through the battery went up, O, and the current through the battery also went up. Those two changes are in the same direction. It's getting a bigger share of more total current. So it gets brighter. But when we play the same game with C, we get a pizza problem. C's share went down from more than half to less than half. But what it's sharing, the battery current went up. So one of those changes is trying to make C dimmer, one's trying to make it brighter. We can't tell with our current model which is going to win. So that's a pizza problem.